Hello everyone, how are you? This video is continuation of the double integrals. Followed the first video, and on the first video we talked about in calculus 2, whenever you want to find the area under the curve, all you did, if you have y equal to x squared and y equal to square root of x, and you find the point of intersection, which is 0, 0, and 1, and 1. What you did, you made your region divided into rectangles, and you find one representative rectangles and find the area of that one. And then you sum it up. Therefore, my rectangle is started from x equal to 0 to x equal to 1, because you have to make either your delta x a fixed number right here. But some students said, what happens if I go back right here and do my rectangles horizontally? Therefore, I'm going to say, okay, you're making your y fixed, because these are delta y, and this one is your f of y for the ith rectangle. Therefore, in here, your y is fixed from 0 to 1, and you do need respect to y. And then in here you have to put a right function minus a left function. Your right function is y equal to x squared, but you have to write it in terms of y. Therefore, your x equal to a square root of y. That's your right function. Minus left, your left is y equal to a square root of x. When you solve for x, it's become y squared, and you did it respect to y because your y was fixed, and you made your delta x in a y value. See, these are all your delta y, and you went from 0 to 1. But in here, these are your delta x. Your x is going to be fixed. You divided it. You divided your b minus a to so many rectangles, and this is nothing except your delta x. Therefore, here you said top function, which is the square root of x, minus the bottom function, which is x squared. And because you made your x fixed, you said, okay, we're going to do it delta x times f of x. And that's how we did it. We came and said, on double integrals, you can say your x is fixed, but your y is not fixed. And instead of dividing in region into a rectangle, you divided your region into squares, and you pick up one of these right here and say this is the representative one, and this is nothing except delta x times delta y, because that's a little bit of x, that's a little bit of y, and then you sum up all of that. Therefore, whenever you do an integration, you have to use differential. Therefore, in here, I put dy dx. Somebody said, why did you change the order? Because in here, I made my x fixed. Therefore, your x is fixed. This one, the outside integral belongs to the far right variable, and the inside is to the far left. Therefore, your x is fixed. But your y then is not fixed. Your y is going to become in that region the bottom function, which is x squared, and the top function is the square root of x. And somebody said, okay, let's integrate this one respect to y first. But remember, whenever you integrate this respect to y, you have to make sure the lower limit and upper limit is the function of the outside variable, because after whatever the outcome is, it has to be in terms of x in order to integrate respect to x. And I'm going to explain the other way around. Therefore, in here, say what function respect to y is derivative is 1 is y, and that becomes x squared, square root of x, and that becomes square root of x minus x squared. This is a function of x. You do it with respect to delta x from 0 to 1, and you get exactly that one back. And somebody's going to say, why do I have to use double integral? Because if I already know the single integral. I'm going to explain this one in a few minutes. But let's talk about what happens if I change the order and I put dx in here and dy here. Therefore, this, because the outside is a function of y, the lower limit and here respect to x has to be function of y. Therefore, I call this one f of y, I call this one g of y. And your y is fixed. Still, the point of intersection is 1 and 1. Therefore, you make your y fixed. But what is your bottom function right here? Your bottom function is y equal to x squared. You have to solve for x in terms of y, and that's become a square root of y. And this one is a top function, which is y equal to x squared. You have to write it in terms of y because your outside variable is y. Therefore, your x is equal to, let me see what I did wrong. This is right, and the top function is y equal to a square root of x. Therefore, your x is equal to y squared. And when you integrate with respect to x, you're going to have x, and your x is from y2, lower limit is square root of y, and you have y squared minus a square root of y, and this is nothing except your right minus a left. But let me see how come in right, in here I put a square, that's right, that's your right. Therefore, my right is y equal to x squared, and that should be other way around. Because this one is the lower, this one is the upper. But for the y, you cannot say lower and upper, you have to say right and left. Your right here, I made a mistake. And no, I didn't make a mistake. Your right is here y equal to x squared, x equal to a square root of y. Okay, that's your right. Your right should not be written in the bottom. The right should be on the top. Therefore, the top should become a square root of y, and the bottom should become y squared. I made a mistake on the top and the bottom. Therefore, your right is y equal to x squared, and your x equals square root of y. That's the top limit. And your left, which is the bottom limit, is y equal to a square root of x and x equal to y squared. Therefore, see, this is your right and this is your left. And you're going to get the same answers. And somebody said, if I can do single integrals, why do I have to do double integrals? I'm going to give you some example. Number one, sometimes I want to find the mass of a plane, a very thin plane. You need to ignore the thickness. This is called laminar plane. And math is always density times area. But the density is always not uniform. Maybe the density here is different from a density here, and is different from a density here because this plane made of different materials. The density, because this is a two-dimension of y and an x, at any given point can be written as a function of x and a y. I'm making this one up. Maybe my density is x squared, y plus 3xy plus a square root of y. Since the density is a function of x and y, you no longer can apply single integral, because single integral, when you say rho times area, and what is your area right here? Your area is f of xi times delta x. From some value to some value. But if your rho is uniform, if your rho is fixed and is the same density all over, you can pull it out and say like we did in calculus 2. But what happens if rho is not there? Then no longer you can use the single, you have to use double integrals to be able to find either dy dx, then you have to be able to find the math. That's number one. Somebody else, okay, give me another example. Sometimes you are asked to find the volume, and maybe the volume is going to become of over that region y equal to maybe 2x minus x squared. and tell me what is that region. That region, this is your y, this is your x, and when x is 0, y is 0, I need my derivative. What is my derivative? Because I want to find my vertex very quick. My derivative is 2 minus a 2x. When I say it equal to 0, my vertex x equal to 1. And when I put 1 here, 1 and 1, that's my vertex. Then what happened when x is 1, y is 1, but what happened when x is 2? You get 4 minus a 4, your y is 0. Therefore, that's pretty much my graph of a parabola. That is the graph of a parabola, and it's going to keep going that way. And now my question is, what happens if I take that piece? And I said, I'm going to build a building over here. And the height of the building is x cubed y minus 2xy. And this is my height. And I want to find the volume of that surface. Therefore, when I find the volume, because the height is a function of x and y, I have no other option to use the double integral. But somebody said, that's my height. X cubed y minus 2xy. And this is base area times height. Base area times height. But somebody said, how do I find the lower limit and upper limit? The region determines the lower limit and upper limit. You got to tell me what is the piece of property. My piece of property is right here. And what is your x value here? 0. What is your x value here is 2. I make it 0 to 2. I make my x fixed. Somebody said, I want to make my y fixed. You can make your y fixed, maybe from 0 to 1. But if your x is fixed, what is your y value? Your y value on the x-axis is 0. But on the y-axis, the maximum it takes is 2x minus x squared. Right now, this is nothing except the volume of an irregular shape. Therefore, sometimes you want to find the mass. Sometimes you want to find the moment. Sometimes you want to find the volume for irregular shape. If it's irregular, you said base area times height. Or if it's a cone, you're going to say, oh, I know what is the volume. It's 1/3 base area times height. But if it's an irregular shape, you have no other option to use the double integrals to do that. Then when you do double integral, this is what you need to know. Number 1, I want you to say this is function of f of x. This is a function, passes the vertical line test. This is also another function, g of x. That's the function. I want to find that area. If it's a function of x, you got to make your delta x fixed and write from a to b. But your y, you have a lower and upper, g of x to f of x. Because you divided this one to infinitely many squares, you have to take one representative. That representative is nothing. The area of that representative is delta x, delta y. But can I write delta x, delta y, or delta y, delta x? I said it doesn't matter. But if x is fixed, you want to write delta y, delta x. If y is fixed, you want to write delta x, delta y. In here, your x is fixed. Therefore, delta x have to be on the last variable, the last integral. And what the inside integral should be, the inside integral is respect to y, but your lower limit and upper limit must be a function of the outside. Therefore, these have to be function of x. Therefore, if this function, I'm assuming that function. Let me see what I can do for that function. I'm going to say, let me write it something like that. This is y equal to e to the power of x. That's the 0 and 1. And this is y equal to a square root of x. You know, in this problem, there is no way I can do even horizontally fixed. I cannot even make my y fixed because on that portion, the right and the left is different from here, the right and the left. In here, I don't have an option to only make your x fixed. Therefore, your x go from here to here. You have to say from A to B. Your y, the bottom function is the square root of x. The top function is e to the power of x. And what is the area of one of these? Should I put dy dx or dx dy? You have to look at this one. If the inside is the function is a function of x, you have to write the opposite variable dy and dx at the end. Means the inside, whenever you evaluate it, has to be function of x. Then you'll be able to integrate it outside. And in this case, these are called vertically simple. Vertically simple means your x is fixed. But sometimes you have function, but it's function of y. Because remember, that graph is function respect to y, not respect to x, because respect to x does not pass vertical line test. Therefore, this is f of y, not f of x. And this one, I'm going to call it g of y. In this case, you can make your y fixed, and you write dy as a fixed one, and dx goes inside, but you need to divide this one to infinitely many rectangles, and the representative is dy dx. How would you write it? You have to tell me if it's a vertical or horizontal. If your y is fixed, your dy must be at the end. And if your x is fixed, your dx has to be at the end. But in here, this one is your inside is x, the outside, the lower limit and upper limit has to be function of y. And how do you do that? Here you have to say left and a right. What is your right? G of y. What is your left? F of, here I made a mistake. This is f of y, this is g of y. This is f of y, this is g of y. The left is f of y. Therefore, whenever you integrate, you have to say f of y your left, g of y is right, but what is your y from here to here? Should I call it from A to B? No, I assign A to B to x. In here I call it C to D. And that's how you find the area. But somebody said, okay, Ganji, what happens if you take that piece of property and build a building on it? And I want to find the volume of that surface. The volume, you go from C to D, from left to right, but your volume need a height. But your z can be function of x and y. I can put my z x squared y cubed, and that becomes dx dy. Therefore, when you find the volume, first, because you're doing it respect to x, that x is constant. No, I'm sorry, because you're doing it respect to x, you have to do this, your y is constant. Because y cube is constant, I can pull the y cube out and only integrate the x squared. Then when you integrate the x squared, because that becomes respect to x, that becomes x squared over a 3. And that should be a y. But these are going to be function of y. You're going to turn this one to a function of y. Multiplied by y cubed when it becomes function of y. Then integrate it respect to y from C to D. And you got the volume. Therefore, double integrals is just not doing the area under the curve. You can find math. You can use it to find the center of a math and many other applications. Therefore, knowing the double integral is important. Therefore, you have to decide it. Are you going to do it vertically simple? Yes, when it's a function of x. When do you do when it's a function of y? They call it horizontally simple. Horizontally simple means y is fixed. And vertically simple means x is fixed. You have to know these two about the double integrals. Then we're going to come back and create another video and explain the many other applications of it very quick.